Hey everybody, sorry that I'm not here today. I actually did end up getting tested and I have COVID. So I hope that I was able to avoid everyone in class and didn't share it with any of you. And I'm really sorry if I did. Hopefully you'll be good to go. But anyways, I am not able to be there today. I'll be back on Tuesday. Shouldn't hurt us because today I'm going to teach the lesson as if I were there. Hopefully, you'll be able to understand it. And then on Monday, I'll give you a review for a test. And then as soon as I get back on Tuesday, we'll go over that review. And then you'll take your test on Wednesday. So we really should be right on schedule for what we had originally planned. So, again, sorry I'm not there today. But if you would, get your notes or your homework out from yesterday. We're going to go over the problems. What I'm going to do really is just kind of put them up here. If you need to look at them for an extended time, go ahead and ask Miss Bowles to pause it, and I'm sure she'll do that for you. But here's number 2. Again, I try to write out all the work, so since I'm not here today, you'll still be able to see it and know exactly what it is that you missed. So there's number 2. Again, if you need more time with it, ask her. I'm sure she'll be willing to go back and pause it. Here's number 4. I'll leave that here for a couple of seconds. Here's number 6. I know that those fractions maybe gave you a little bit more trouble, but I think you guys probably would be all right. So that's number 6. Of course, we did number 8 together, so you didn't have to do number 8. So here's number 10. With that one, of course, there was no value out here. There was no k value. So after we got finished doing our multiplication and our distribution, there wasn't anything else to combine like terms with. So that was it. And then also, don't forget, if you didn't put negative 0.5, but if you put negative 1/2 instead, that's just as good. It's just as correct. And then last one, number 12. Again, if you were not able to see some of those, if it went off too fast, just ask Ms. Bowles to rewind it. The video today is not very long because this is actually a pretty easy lesson the way we get to do it today. So I think it'll probably take us maybe about 15 to 20 minutes to explain today's lesson. All right, so there you have it. So at this time, Ms. Bowles has either given you or will be handing to you today's notes. And today's notes is we are trying to go from standard form to vertex form. So you have a piece of paper now on your desk that looks like this. This is what we're doing today. Now this one looks a little wonky because it just didn't transition correctly over to this file, but anyhow, it should look good on yours. You also need a graphing calculator, so if you did not grab one of those, please go ahead and grab a graphing calculator because you're definitely going to use that today. Now, here we go. So, converting from standard form to vertex form, there are really 3 good ways to do it. There are 2 that I would consider easy, and then there's one that's a little bit more challenging, but it's kind of what you need to do in later things with some stuff in pre-calculus. So I'm not even going to show you guys that. What I'm going to show you instead is the 2 easy ways. And I'm going to show you both of them with the first example. But then after that, we're going to go with the one that's just the easiest. So let's go ahead and get started. I want you to remember, and I probably would reverse this order if I were writing these notes again. The first thing I think that I want you to recognize is don't forget the connection between A when it's in standard form and A when it's in vertex form. So when you write this equation, I would say don't forget whatever's out front in standard form has to be out front in vertex form. So that's number 2 in the notes. Number 1 is what we're going to do in 2 different ways. One, and the easiest way to do it, is just to grab your graphing calculator and find it. You're going to find your vertex on your graph. The second way, and I'm only going to do it with one problem, but this is the way that I'm going to show you secondly is if you're at home and you don't have a graphing calculator, you can't say, well, I couldn't do it because I didn't have a graphing calculator. You can do it even without a graphing calculator. And you do it the same way we talked the other day when we were learning standard form. You use the equation for the axis of symmetry, which is x equals negative b divided by 2a. Then you take that value, and that's the x value of your vertex, and you use it to find the y value. So you end up finding your vertex using that equation. So once I know what a is, and once I have my vertex, I can go ahead and go to my vertex form, and I can just write it just the way that you know that it is. You do x plus and x minus based on your x value of your vertex, and don't forget, be sure to use the opposite sign of the vertex. And then, of course, you're going to put that squared on the outside. That's important. That's what represents the fact that it's a quadratic. And then the last thing is you're going to write the y part of your vertex outside the parentheses. And we already said that it is what it is. So you add it if it's positive, you subtract it if it's negative. So here we go. We're going to do these using both methods, okay? So first, let me show you the way that we're going to do it the rest of the time. We're going to go to our graphing calculator to find the vertex. But first, don't forget about your y-intercept. What is the y-intercept of this problem number 1? Hopefully you remember that when it's in standard form, your y-intercept is your constant. So my y-intercept is 18. But a lot of times you'll see it written as an ordered pair, so they write it as 0, 18. Remember, your x value is 0, your y value 18. All right, so let's use our graphing calculator to find our vertex. We're going to go, and I would encourage you guys to go ahead and clear the memory, second plus 712. Then we're going to go to y equals, and we're going to type this equation in just like we see it. X squared minus 8x plus 18. And we're literally going to graph it, and we're going to look. This is my vertex, right? So that's at 1, 2, 3, 4, positive 2. 4, 2. But please, don't just go ahead and write 4, 2. I want you to go confirm it with your table. So go to second graph, go put 4, 2 in the middle, and make sure it's symmetric around it. So sure enough, if I put 4, 2 in the middle, see how these are 3s, and these are 6s, and these are 11s? That confirms that our vertex here is 4, 2. So let's write that, 4, 2. So now we're ready to write our vertex form of this same quadratic that we have above. So here it is. Ready? F of x equals, go back up above and look at the formula, a. Well, what is that a value that's up here at the top? Well, it's understood to be a 1. So that's the same thing we're going to have out front here. It's a 1. Open parentheses. We're going to put our h value in here. Well, what is that x value of the vertex, h? It's 4. Remember the rule on that? If it's a positive 4, it actually looks like x minus 4. We're going to put squared on the outside. We're just following our steps here. And then the last thing, we're going to put the y value of our vertex, k, and it is what it is. So that's a positive 2. And voila, there is the vertex form of this quadratic, x minus 4 squared plus 2. How easy is that, right? I mean, none of you guys probably struggled with that. You probably understood it very well. So that's it. That's what we're doing. Now, I do want to show you the other method in case you happen to be at home, you don't have a graphing calculator, you don't have access to Desmos online, and you just want to find the vertex without it. We're going to do the same thing we did on Wednesday when we studied standard form of a quadratic. We're going to use x equals negative b, that's negative 8, divided by 2 times a, which is 1. Well, remember, negative 8 is positive 8, and positive 8 divided by 2 is positive 4. So look at that. The x value of my vertex is positive 4, just like we got. But then I'm going to plug that into y equals, every time I see x over here, every time I'm going to plug 4 into it. So I'm going to go 4 squared minus 8 times 4 plus 18. Well, 4 squared is 16. 8 times 4 is 32. So 16 minus 32 is negative 16. And negative 16 plus 18 is, sure enough, positive 2. So just like we got when we looked at our graphing calculator, we got the same thing here. Here's the point. The two easy ways to rewrite standard form into vertex form is to make sure we find the a value, which is given, and we find the vertex. So whether you find that vertex using your graphing calculator, or whether you find that vertex using the equation that we learned, x equals negative b over 2a, I'm fine with it. So for the rest of these problems, we're going to use our calculator, because I know that's what you guys prefer. And you're going to have time in class to do your homework where you'll have your calculator. So let's do these, okay? And I don't want to rush these, but I do want you to realize they're not as hard as sometimes we make them. So first thing I want you to recognize, what is my y-intercept on this problem? What's your constant? It's negative 5. So I'm going to write 0, negative 5 as an ordered pair. What's my vertex? Well, let's go to our graphing calculator. Let's go to y equals. Let's clear that thing off. And let's type in negative x squared plus 6x minus 5. Let's graph it, and let's see if we see it. To me, it looks like it's at 1, 2, 3, positive 1, 2, 3, 4. It looks like it's at 3, 4. Let's go confirm that. Second table, look at 3, 4, and sure enough, right here at 3, 4, is it symmetric around it? You got 3, 3, you got 0, 0, you got negative 5, negative 5. So sure enough, my vertex is 3, 4. Go write it. Now we can write the equation for this quadratic. So here's what I do. F of x equals, guys, go back to your original equation. Do you know what a is? It's negative, right? You don't have to write anything else. It's just negative. So we're going to write negative on the outside. We're going to open up those parentheses. We're going to put our x value of our vertex, we call it h. We're going to put it inside. Remember the rule? It's the opposite. So it's positive 3, so we know it looks like x minus 3. We're going to write our squared on the outside. And then on the outside, it is what it is when it comes to that y value. So it's positive 4. And boom, just like that, we're done. Okay? Pretty easy, I hope that you see. Let's keep on moving. I don't want to delay any longer. If you need to, you can rewind and you can watch it again. So here's how easy this is, okay? Ready? Y-intercept. Hopefully you said 0, 13. All right, vertex. We go to our calculator, clear it off, type in 2x squared minus 12x plus 13. We graph it and we see if we can see it. Here it is. That looks like it's at 1, 2, 3, negative 1, 2, 3, 4, 5. It looks like it's at 3, negative 5. Let's go check. Second table, 3 happens to be right in the middle as it is. Is it perfectly symmetric around 3, negative 5? Yep, it sure is. 3, negative 5 is my vertex. So we're ready to write our equation. F of x equals, look at your original equation. What was a? So that has to stay a. It's the value out front. Then you're going to write your parentheses. What's my h value? 3. How are we going to write that? X minus 3 squared on the outside. And then your k value is what it is, minus 5. Done. Okay? Very, very simple. Let's do 2 more of these, and then I'm going to give you your assignment to work on in class. I'll tell you which ones. So let's go to number 4. My y-intercept, 0, 4. Right? There it is. That's my c value. Then, of course, I'm going to go to my calculator, go to y equals, and let's type it in. X squared plus 4x plus 4. Let's graph it and see if we see it. Looks like it didn't go up or down, right? It just went left 2. So I think it's at -2, 0. Let's go look. Second graph. Let's go put -2, 0 right in the middle, and let's see if I was right. So here's -2, 0, and sure enough, it's perfectly symmetric around it. So -2, 0 is my vertex. So let's write our equation. F of x equals, guys, what was the a value to begin with? It was a 1. It's still a 1. So we open our parentheses up. Inside, we write the x value of our vertex, which is -2. But remember how you do it? It's got to be the opposite. So it's x plus 2, right squared on the outside. And do I need to write anything outside for 0? No, I don't. You can if you want, but you do not have to. Okay, last one, number 6. What is my y-intercept? Well, do you see a constant out here? I don't see a constant. If there's no constant, then my y-intercept is 0. It's 0. All right, let's go find our vertex. I'm going to go back to my calculator. I'm going to type it in. I've got negative x squared. Remember, don't put minus x squared, put negative x squared. Now we put minus 2x. And that's it. So let's graph it. It looks to me like it went left 1, up 1. Left 1 is -1, up 1. So -1, positive 1. Let's check. Second graph. Let's put -1, positive 1 right in the middle. And sure enough, is it symmetric around it? Absolutely. So -1, positive 1 is my vertex. So here's my final answer. F of x equals, guys, what's my a value? Negative. Open parenthesis. How do I write my h value? X plus 1 squared. And then how do I find my y? Positive 1. So negative x plus 1 squared plus 1. And that's it. That's all there is to it. Now, on the back side of this worksheet, you have more problems, and that's where you're going to find your homework. I want you to do all of these problems except for number 5. So I want you to do numbers 1 through 4 and 6 through 8. 1 through 4 and 6 through 8. Okay, that avoids us having to deal with any that are fractions. So that is your homework for right now. I think you'll have plenty of time to finish it now. And then, of course, on Monday's video, on Monday's video, I'll have just a brief explanation for those answers. And then you're going to get time to work on a review in class. Okay? So I hope you guys have a wonderful weekend. Sorry I'm not there. Hope you guys are all doing well. We'll see you soon.